Hey guys, welcome back to AlgoYogi. We are doing binary search series, and our next problem is house robber fourth. So this problem is also not in my list, but it's of category Koko eating bananas and capacity to ship packages within D days. So I'll upload it right after those videos. Okay, so there are several consecutive houses along a street, each of which has some money inside. There is also a robber who wants to steal money from the homes but refuses to steal from adjacent homes. Why? Because there might be some alarm system or whatever. We're trying to help the robber here, although we shouldn't. I don't know why they have these negative problems here, why they giving robbers ideas or whatever. The capability of the robber is the maximum amount of money he steals from one house of all the houses he robbed. So that's capability is like if he chooses to rob basically like let's say 5 houses. So whatever the maximum amount that he steals from one house, that maximum amount is the capability of the robber. Now you are given an integer array nums representing how much money is stashed in each house. More formally, ith house has basically nums I dollars or rupees or Pakistani dollar. You are also given an integer k. You're also given an integer k representing the minimum number of houses that robber will steal from. Okay, so that k represents the number of houses, minimum houses that robber will steal. So although this doesn't really matter much, because I'll show you later how this is a problem of choosing that range, and within that range you're trying to basically find that minimum capability of the robber. So it is always possible to steal at least k houses, return the minimum capability. So this is, we will always basically have k houses that we can steal from. It's just the capability that we have to choose the minimum capability from those number of houses. If we choose, basically what I really mean is we have these number of houses. In the first example we have basically 4 houses. We need to steal from 2 and return the minimum capability. So you could they have shown us here how many pairs you could make and return the minimum capability. Basically, if you choose to steal from 2 houses which are not neighboring, you cannot choose from the neighboring houses. So let's see how we can approach this problem. So we have basically four houses. We have 4 houses, and then these are those 4 houses. First house has $2, next has $3, $5, $9. Robber has been asked to basically steal from at least 2 houses. Okay, so we need to have basically at least 2 houses to steal from, and they cannot be neighboring. These 2 cannot go together, these cannot go together, these cannot go together. So what could be the pairs? This could be one pair, this could be one pair, these 2 could be a pair, these 2 could be a pair, these 2 could be a pair. Okay, now so what do you think? Since it's the capacity, so there is, let's say, this capability, not capacity, there is this variable c that way is basically max of all houses stolen. Okay, this c is basically the maximum of from all the houses that we have stolen the money. Okay, so in this case, if we were choosing a pair, basically 2 and 5, the max of 2 and 5 is basically 5, which is this capability. Then if basically we were choosing to steal from 3 and 9, then that will be 9, that will be our c. How about another scenario? That will be if you choose 5 and 5 and 2 is already done. 9 and 3 are done. 9 and 2. So 9 and 2 is another possibility because they are not neighboring. So 2 and 9. Here also it would be 9, and that is our maximum c. So if you see over here, these For these three pairs we could choose to steal from, and the minimum capability of the minimum capability out of these 5, 9 and 9 is 5, and that will be our answer. And we got it by choosing to steal from the 0th house and basically second house. All right, so let's do some stealing. How are we going to do it? So we know that this range of capability would be basically in minimum and maximum from these money that is given in these houses. So what is this range that we are going to have our capability? Sorry, I keep saying capacity, and that's coming from the previous problems that we have solved. So that would be basically from the minimum here is 2 and then 3 and whatsoever. I don't know, I'm gonna just remove this, and until 9, which is the maximum here. Okay, so this is this range of capability that we can have, and we have to basically return the minimum capability. So, and that too, when we choose that capability, we are able to find k number of houses that we can steal from, and they are not neighboring houses. So what we'll do is brute force approach, linear fashion search. That is, we have this range now, we have this range. We start with our lower range, which is 2, which is minimum from these nums. We have this, and then we keep basically searching. So what we do is, like, how about our capability is 2? Our capability is 2. If we choose capability 2, then we can basically steal basically capability is the maximum of the houses that you can choose. That then you can only choose from 2. If 2 is your capability, which is basically the maximum of all the houses that you can choose, this is the only choice you have. Then you can't steal from 2 houses, k number of houses. Then this does not go well. So what you do is you increment, you test the next number, which is 3. If 3 is your capability, then you can choose from these 2 houses. Can you actually steal from these 2 houses? No, because they're neighboring houses, so you can't. So what you can do is you can only choose from one house that is only has 3 value. So what do? You choose 4. What if you choose 4 as a capability? Then you can again either choose from 2 or choose from 3. Then also you fail. You can't basically steal from 2 houses still. But if you choose capability 5, then see what happens. If your capability is 5, then what's happening is you could choose from 2 and skip this house, and then choose 5. So this one and this one, if you choose these 2, you were able to steal from 2 houses. So your number of houses that you could steal from are basically your conditions are met, and also this capability that you found, that will be your answer. That's what you returned. You were trying to maximize actually you were trying to minimize the capability. You could still have a capability could be like 9, and then you could choose any pair of these, but or 10 or whatever, but we want to minimize the capability. So here 5 is the minimum capability that you found, and that will be your answer. So 5 is your answer. 6, 7, you could keep trying and you will still find these answers, but you don't want that. You wanted the minimum number that that can let you steal from 2 houses which are not neighboring, and this k number is met. So now that will be our brute force approach. That is was like searching in the linear fashion from this range of these capabilities that we just decided from minimum and maximum of nums. Now how about we improve our solution? In this case, in the linear search, the time complexity would be basically big of n into k. If not k, we can call it m. So log n into m, and that m is the basically this length of this range that you have from minimum and maximum between these nums. Okay, but we can definitely improve. We have been improving by basically when you have this range from 2, 3, 4, 5, 6, 7, 8 and 9, you have this range, then what you want to do is you search using binary search. You have left and right pointers. I'm gonna move this little up so it looks a little nice. Okay, so how about you have left and right pointers, then you find out the mid, in this case 9 plus 2 divided by 2 would be 5, that is our mid. And now using this value, which is 5 now, how about we basically run a linear search on nums. So for num, we're not going to do is using like that. We'll have to do it basically a while loop, because we'll have to skip these neighboring values. So what we'll do is we'll start like I at 0 to here. What we are really trying to do is calculate the number of houses that we can steal from. Okay, so what we'll do is have num house, num h, initially 0, I is 0, and while I is lesser than len nums, then we keep going. And what we trying to do is if nums I is basically less than or equal to the capability that we just chose, which is m right now, then we will increment the number of h, we'll increment that number, so that will go plus plus num, and we will increment I by 2. Okay, we will increment I by 2, and that is because we want to skip. If we found some number basically under the capability, below the capability, we could choose that house to steal the money from, and then we can skip the next neighboring house, and this will return the number of houses that we could steal, and we'll return from there. Okay, and if this number is basically greater than or equals to k, then we could choose that as our answer, the minimum capability. But we know that we could go more minimum, so we'll move our right pointer basically below this mid and then keep doing the same thing. And now at this point, like, okay, so I don't like to go like really just walk through the entire process, but like leave you guys somewhere in the middle so that you can run through your examples, right? Okay, so and then that will bring down the time complexity to big of n into log m. Log m comes from here. If the length of this range is m, then that's what I meant. The time complexity would be log m into n. N is the size of basically these houses. Let's go to code editor and write this solution down. So brute force, I'm assuming you can write. Brute force you'll write, and let's write the optimized solution. So left and right pointers basically is the range. Range here will be starting from the minimum of nums, and this will be maximum from nums. Okay, maximum from nums. So now we'll have our while loop. I want to leave some space here because I'll be writing like a helper function. I'll tell you why. Okay, so while left is lesser than or equals to basically right pointer, find out the middle, right left divided by 2. Now let's call this function num houses from find num houses. Okay, num houses, and this is the definition we will write here, which will take some number, let's call it we can call it C capability, or C, and now we'll try to find if using this capability could we find these non-neighboring integers in nums that were basically we could steal from those, and they are basically under capability C, and then return that number of houses. So let's say number of houses is num houses are 0, then I starts with 0, then while I is less than len nums, and if nums I is less than or equals to basically the capability C, then what we can do is we can increment this number of houses. I wanted to write it in the end, but let's just write it. Okay, we can increment this, and I will basically by incremented by 2. That's because we want to skip that neighboring house, and then let's return this num houses. Okay, let's return this num houses. So we have this small helper function, find num houses with C capability. Okay, so now num houses comes from, so we don't have to actually have it like this. We could just simply say if find num houses, we call this function on what, on M, if this particular number that it just returned, if this is greater than or equals to K, that's the number of houses we want to steal it from, using this as our capability, which is M. We're finding it in this range. So what we'll do is if this is the scene, then we'll have like a variable called result, and initially that capability will be basically the minimum of from the nums. That's the minimum capability that you can have, and we will basically assign this to as minimum of, not actually minimum, we'll just assign it like that. So rest will, because it satisfied the condition, then we don't have to have it as minimum. This will only satisfy this can actually satisfy actually, yes, this is right. We will have to have it as maximum, and then we're trying to minimize this from result, and we have this M. Now we are choosing as this capability that will satisfy our condition. Then we want to basically decrement our right pointer to mid -1, because we could always find a smaller capability that will satisfy our condition, basically choosing K number of houses with that capability. So else this did not satisfy, we have to increment our left pointer to basically mid +1. So left goes mid +1, so that we can find a bigger capability, and so that we are able to steal from K number of houses. All right, and then in the end we can just return result. Okay, let's try it out on the test cases. So I'm gonna run it, and there might be some. Okay, so just a little problem over here. We need to have this else case to increment the pointer by pointer by 1. That's why I was getting stuck in this infinite loop. That's what we don't want. So I think now we can run it again. This time it should be fine. Yes, it is. Let's submit it. Okay, yeah, awesome. So let's write down the time complexity of this solution. Brute force was different, and I guess you can write the solution yourself. So if n into log m, where n is basically the length of nums, and m is the length of the capability range. All right, space complexity would be big of 1, which is constant. Okay, so you can now have a nicer look. This is that helper function. helping us find the number of houses that are not neighboring and satisfy under the capability number that we just chose using this binary search right here, finding the mid. And we keep reassigning these left and right pointers, trying to basically minimize this number that we choose, but at the same time which satisfies this particular condition comes from find num houses, and these houses need to be greater than or equal to this k that was given to us. All right, so see you guys later in the next problem. This might be basically the last problem that we just solved in this category. Koko eating bananas, capacity to ship packages. All right, see you guys later then. Until then, bye bye. One more time, you can have a look at the code. Okay.